All right, ladies and gentlemen, today we're going to be working with the one sample t-test for means. Please adhere your notes to your notebook. With the one sample t-test for means, we're again going to follow that 6-step process. Step number 1 is to name our process. Here we're going to be working with quantitative data, and we're going to be working with one sample of data. So the name of our hypothesis test is a one sample t-test for means. We do have a degrees of freedom of n-1. Step number 2 are hypotheses. Remember, since we're working with quantitative data, we're going to be working with mu. Our null hypothesis, no difference, no change, nothing is going on. Mu equals whatever our hypothesized value is. Our alternate hypothesis, something is different, something has changed, something is going on. Mu is less than, greater than, or not equal to that value. Don't forget to define your variable. Mu is the true average, whatever your context is. Don't forget the word average or mean is necessary. Step 3 are our conditions. Our conditions pretty much stay the same. We need good quality data and we need normality. For good quality data, we need that randomization, either a random sample or a random assignment of treatments. For normality, remember with quantitative data, we need to check for one of the following. Either it's stated as normal, we have a large enough sample, n greater than 30, so that the central limit theorem applies, or when we actually have data, we need to graph it to see if normality is reasonable. Please remember to show your graph. On step 4, we're going to actually do some math. Our test statistic is called a t-score instead of a z-score because we're working with the t-distribution. The test statistic is still value minus mean over standard deviation, x bar minus mu over standard deviation over the square root of n. Remember, x bar is your sample's average, mu is the true average for the population, which is your null hypothesis value, s is your sample's standard deviation, and n is your sample size. Like before, the p-value is the probability that comes from that test statistic. It is the probability of obtaining a sample mean value as extreme or more so if the null hypothesis is true. However, most of the time we're going to use our calculator to find these two values. Remember to go to Stat, scroll over to Tests. You're going to look for the t-test, which on the TI 8384s is the second option. Don't forget to write down what you type in and your results. Steps 5 and 6 stay the same. With step 5, we need to make a decision. If our p-value is low, we're going to reject the null hypothesis. If our p-value is high, we're not going to reject the null hypothesis. And like before, 5% is typically our cutoff value for low. For our conclusion, if we reject the null hypothesis, that means we do have evidence of the alternate. If we don't reject the null hypothesis, we do not have evidence of the alternate. Make sure you are writing in context. So let's look at an example. A coffee machine dispenses coffee into paper cups. You're supposed to get 10 ounces of coffee, but the amount varies slightly from cup to cup. Lately, customers have been complaining that the machine is shortchanging them. You decide to investigate and gather a random sample of 20 cups. The mean amount dispensed is 9.85 ounces with a standard deviation of 0.2 ounces. A histogram of the data shows a roughly symmetric distribution with no outliers. Based on this data, is there evidence that the machine is shortchanging customers? Like always, make sure you pause the video, try the step on your own, and then unpause the video to see how well you did. Step number 1, we need to name our process. We're working with quantitative data because we're looking at amount of coffee in a cup. We have one sample, so we're going to do a one sample t-test for means. And our degrees of freedom here is 19 because our sample was 20 minus 1. Our null hypothesis, no difference, no change, nothing is going on. The coffee machine should dispense 10 ounces, so that's our null hypothesis. Our alternate, our customers think that the machine is shortchanging them. They believe they're getting less than 10 ounces on average. Mu here represents the true average amount of coffee dispensed by the machine. Step 3, we need to check our conditions. We need to check for randomization, and we need to check for normality. Randomization, it is stated that we have a random sample of 20 cups. For normality, we need to go through that checklist. Does it state that it's normal? Do we have a large enough sample size, or do we have data that we can graph? Here it is stated that the histogram is roughly symmetric with no outliers, so normality is met. Step 4, we need to do some math. If you're feeling really ambitious, feel free to do the t-score by hand. The t-score is x bar minus mu, that's your sample's average minus the hypothesized value of 10, divided by the standard deviation over the square root of n. That gives you a t-value of negative 3.35. However, you can use the calculator. You're going to go to Stat, over to Tests, to the t-tests. And when you first bring it up, it's going to look like this. And notice it says Input Data or Stats. Data is if you have a list of information that you've typed into L1. Here we have Stats. So click over to Stats. It asks for mu0, x bar, sx, and n. That's your null hypothesis of 10, your sample's mean of 9.85, your sample standard deviation, 0.2, your sample size of 20, and you're interested in less than. That's your alternate hypothesis. When you go down to calculate, it gives you a t equal to negative 3.354 and a p-value of 0.0017. That p-value is what we're going to use to make a decision. So step 5, we're going to make a decision based on the p-value of 0.0017. That is a very low p-value, so we will reject the null hypothesis H sub O. If we reject the null hypothesis, that means that we're going with the alternate. We believe that there is evidence that the machine is shortchanging customers and dispensing less than 10 ounces of coffee on average.